G'day viewers. Looking at Newton's laws of motion here, and this is obviously paraphrased because he spoke Middle English. He didn't speak modern English like you and I speak. So we have to paraphrase his laws, and I think most of you will agree that this is correct. If not, make a comment and we'll see what you reckon. Newton's laws of motion, the first law is an object at rest will remain at rest, and an object in motion will remain in motion unless acted upon by an external force. The second law is the acceleration of an object is proportional to the net force applied to it and inversely proportional to the mass of the object. That's the second law. Now the third law says for every action there is an equal and opposite reaction. For those of you that can recite Ohm's law, it states that the current in an electrical circuit is proportional to the voltage and inversely proportional to the resistance. That's a big clue right there, that when applying this to gravity, it's very similar to electrical behaviour. So we'll just get rid of this and I'll show you the formula, simple formula, and we'll discuss gravity. Before I get on to gravity, Newton's laws don't have to necessarily involve gravity. They could be in zero gravity, and you could be talking about a rocket, you could be talking about applying thrust, pitch, yaw, roll, anything, and you can predict the actual trajectory or path of the object. So I'll just get rid of this writing and we'll write down a few formula. A lot of people won't agree with it, some people will see it, but it's actually brilliant when you reduce it to simple mathematical equations. Simple. You always try to simplify it down to the most easily explainable system. So we'll get rid of this and we'll continue on with this video. So here we are, we've got the final results. I had checked these just to make sure I didn't make any mistakes in my off-the-cuff calculations. The first thing is we'll explain meters per second per second. This is so simple. In the case of gravity, we've got gravitational force of 9.81 meters per second. So for every second, you add another 9.81 meters per second. So for example, here we've got 5 seconds. It's equal to 49.05 meters per second. If you had 10 seconds, it would be 98.1 meters per second would be your final velocity after a time duration of 10 seconds. Where we start getting into squared seconds, or 1/2 of AT squared, that's the distance. That calculates the distance in the duration of the fall. So as you can see, in 1 second, it's only half, it's 4.905 meters. And that is because we're starting off at 0 meters per second velocity, and then we're adding the final velocity after 1 second will be 9.81 meters per second, but the distance travelled will only be 4.905 meters. I've written those out. You can graph those out for yourself if you're a student. You'll see that the distance over time travelled will form a parabolic curve, and that means that the actual gravitational equation is, what do you call it? That's right, quadratic. and the velocity is simple addition or multiplication for the number of seconds travelled. So I've given all the values over 5 seconds, graphed them out. You'll see that the acceleration is linear and the actual distance travelled is parabolic. So I hope that clears up everything, and it should make it really easy for you to understand gravity. And what I've used there is SI units. If you start going miles per hour and feet per second, you're just defeating your own purpose. It's really easy to use the metric system, SI units as they call them, and then you can convert this to tons or grams or whatever you want. But Newton, he was definitely a very smart man, and these the math here all fits his laws of motion perfectly. I can't do any better. Nobody can. I don't think anybody can change the actual outcome. So I hope this helps any of you younger students that are going through this at school. You wrap your head around this and it will just open up and become immediately clear to you. Anyway, cheers and all that, and I've got to go and do some bits and pieces now, so we'll catch you next time.